Okay, let's continue our discussion of the planets with everybody's favorite planet, at least my favorite planet, and Neil deGrasse Tyson's favorite planet, Saturn. Look at it. It's just so beautiful. Wow. And it's my favorite thing to show people when the first time they come to an astronomy night and see Saturn in our telescope, and it looks like it's a little sticker that somebody's placed on there. It looks fake. It's just so perfect and just, I don't know. It's just very interesting, beautiful object. Let's get right into it then. This was the last of the planets for thousands and thousands of years. To ancient people, this is the farthest planet you can see easily with the naked eye. And so it was the last one. That's why it's the last day on our week. Saturn Day. So there's a reason behind that. Saturn was the father of Jupiter in the Roman mythology, by the way. And was, I think, the father of agriculture or something like that. The god of agriculture. So not sure why that is. But anyhow, let's get to the science. We are now twice as far from the sun as Jupiter was. Twice as far. So you know from the inverse square law that if you're twice as far, you're actually only receiving 1/4 as much sunlight. So we're far. We're out there. Okay, we're now measuring distances in billions of miles from the sun. And obviously it's cold. It's cold, and you're going to see the effect of that on Saturn versus Jupiter. It is fainter for that reason as well. It doesn't receive as much light. Of course, it's fainter than Jupiter. It's also slightly smaller than Jupiter, but being farther away is the main thing. Still pretty bright in the sky, not too bad. Kind of comparable to bright stars. Okay, so here's the tail of the tape. This would have seemed so impressive not too long ago. But once you've had Jupiter, then suddenly Saturn, 95 times the mass of the Earth, so what? You know, Jupiter was over 300 times the mass of the Earth, 9.5 times the diameter of the Earth. Not bad, almost as wide as Jupiter. And by the way, with the rings, it actually is wider than Jupiter, if you counted the rings. But, again, still smaller and less massive than Jupiter. Here's finally something that Saturn beats Jupiter at, though. Density. It is the least dense planet in our solar system at 700 kilograms per meter cubed. That's actually less dense than water. So it is the only planet that would float in your bathtub. You need a pretty big bathtub for that demonstration. Of course, it is a gas giant. And this time it truly is. I sometimes call Jupiter a liquid giant. Saturn is more of a truly gas giant with the hydrogen, helium, a lot of it by volume being gaseous. Here's one of our models here showing the size of it. You know, again, I kind of think of the solar system as being this, you learn in elementary school 4 gas giants and 4 terrestrial planets, but I often break it down into smaller groups, and they have really 2 large planets that are similar, 2 medium planets that are similar that we'll get to later, and then the small planets, terrestrial planets. Anyway, let's talk about the rotation. Not surprisingly, it is a differential rotation, just like Jupiter. It rotates fastest at the equator, just like Jupiter. And as a matter of fact, it's just about the same speed with about a 10-hour rotation at the equator, which is almost identical to Jupiter as well. The only slight, so I think Jupiter technically spins faster, it gets the title, but Saturn, being gaseous, being not as dense, has actually flattened out more. Remember, that's called conservation of angular momentum, or in my class, the law of pizza dough. As something is spinning, it flattens out around that axis. In this case, it's actually 10% farther to go around the equator of Saturn than to go around its poles. So a sizable difference, more than any other planet. The word for that is oblateness. We say it is more oblate than the other planets. It, somewhere down in there, has a quote-unquote rocky core, maybe perhaps not solid, but made of heavier materials, 15 times the mass of Earth. Okay. The famous ring system. We're going to do a lot about the rings later on. But first, the rings are tilted by 27 degrees, but that's a little misleading because what's really happening is the entire planet is tilted by 27 degrees, and the rings are just around the equator. Why does that make sense? Well, if it's fatter at the equator, if it's wider there, then there's more gravity there, and that's where the ring particles settle down. So that actually makes a lot of sense. So since the planet's tilted by that, the ring is tilted by that, which means we see it very, very differently during Saturn's year. So when Saturn is tilted towards us or away from us, or in other words, towards or away from the sun in its summer and winter, we get to see the rings really well. But when the sun's rays are hitting at its equator, it turns out that the rings practically disappear. Take a look at so that would be in its spring and fall. Look at the difference. Look at the top. And we've seen it like this. It takes Saturn almost 30 years to orbit the sun. So I have been teaching astronomy now this is my 20th year of teaching it. So it's gone 2/3 of its way. I've taught for 2/3 of a Saturnian year, if you will. And so I've seen these changes, and it's dramatic. Here again in the Saturn fall or spring, the rings, you can't even see them. They're so incredibly thin. I love it when it's like it is down at the bottom right here, where the rings are they're so bold, and you can actually see a couple of the gaps in the rings and so forth like that. So anyway, let's move along here. You can see there's a little moon right there hanging out, probably the moon Mimas, perhaps. And then we see a shadow of the moon, of the rings, on the planet, and the terminator line of Saturn. Just beautiful. One of my favorite moments at an astronomy night was years ago. It was the same night that this picture here was taken. I didn't take this, but where there was a transit of Saturn and the moon, and I remember setting up the telescope, and it looked like the moon had a little earring sticking out. It was really cool. Look at that. That's pretty neat. Pretty neat time lapse. I'm not sure. It's only probably a matter of minutes there in that time lapse. Okay, let's talk about the atmosphere a bit. Not as many storms, not as many belts and ovals. Why is that not a surprise? Well, because it's colder. Remember, heat drives weather. And so you're not going to have as much internal heat. You're not going to certainly have as much heat from the sun. It is hydrogen and helium. However, you'll notice here, that's quite a bit less helium than expected. That's about half the percentage of helium that Jupiter has. You also have some methane and some ammonia. Ammonia kind of gives Saturn its sort of goldish color. It doesn't have much color at all, but whatever color it has is due to ammonia. So anyway, that having less helium is a bit of a mystery. It's a bit of a mystery. We'll answer that in a little bit as to why there's a lack of helium. Let's call that mystery number one. Again, it's hard to find photos. People tend to really color Saturn for some reason. I just think it's beautiful as it is there, but it doesn't have much color at all, actually, in a telescope. Gosh, so gorgeous. This is what we learned back in the 70s and the 80s, that it wasn't just like one or two or three giant rings. They're just thousands and thousands of different rings. We'll talk about some of them later on. You can see just barely some of the stripes there on Saturn, like Jupiter has, those bands and belts and zones. All right. But Saturn has some weather that even Jupiter can't top. Yes, Jupiter has the great red spot, and that's cool. But trust me, Saturn has some really cool stuff of its own. This was pretty neat. You had a storm in 1990 that stretched out, that just came out of nowhere and stretched out. And then all of a sudden in 2010, same thing happened again. And that was cool for my classes to get to kind of watch that evolve over a matter of a few months. And then it was gone again. But it really looked a whole lot like Jupiter there for a few months. 2006, we discover a giant storm, basically sort of like a hurricane, on the south pole of Saturn, which was awesome. Again, and not really expected. But the greatest thing about it, I mean, the one that just blows everybody's mind, is on the north pole of Saturn. You ready for this? This is just crazy. It has a hexagon a six-sided storm. Yes, I will show you a picture in a moment. This was first seen by Voyager all the way back in the 70s, late 70s, and then I don't think anybody imagined it was still there. And then Cassini rolls out there, and I guess 2004 or 5, and it's still there. It's still there. This is so crazy. All right, let's take a look first. Here's that storm from 2010 that kind of brewed up out of nowhere. Made it look very Jupiter-like. Pretty cool. Here you can see how it expanded through the first few months there of 2011, and then dissipated by the late summer. Pretty cool. Then you have this hurricane-like storm on the south pole of Saturn. Look at that. I mean, that one even seems to like an eye wall, like a real hurricane. And there you see it in comparison to Saturn itself. And then we get to the just absolutely, I mean, on my list of really cool things in the solar system, this is pretty high up. The hexagon. The hexagon. Look at it. Let's see if we can. Here we go. 1, 2, 3, 4, 5, 6. 6 sides. It's a storm with 6 sides. Imagine seeing that on the Weather Channel coming across the Atlantic towards us here in Florida. I think we'd all be a little freaked out. Pretty neat stuff. Pretty neat stuff. There's kind of a look inside it. That it does have depth to it, the hexagon. Wow. Really, really neat. They actually had so much trouble explaining this. They finally did in a lab. On the left here, you see where they took a flow of liquid or something like that, and actually, I guess it was liquid, I'm not sure, and were able to simulate, actually, show that in nature you can have, with just the right flow and the right angles, you can actually create a sustainable hexagon. So it has been proven in the lab. And then this is just, I don't put cartoons in too often, but I thought this one was funny, where different science teachers are arguing over who has the coolest stuff to talk about in class. So here we have bio teachers saying, well, we have DNA and, synthetic life. And I'm the astronomy teacher saying, yeah, we have a hexagon on Saturn. And then the chemistry teacher, we have femtochemistry. I'm like, there's a hexagon. And then finally the physics teacher, I mean, this is pretty good stuff. Particle accelerators, quantum teleportation, but boom, hexagon. Hexagon wins. I mean, there's just so many cool things, and there are so many cool things in astronomy. It's crazy. All right. Very quickly here, let's just finish up this section. Saturn has a metallic hydrogen layer, just like Jupiter did. Not as much. And so, as you can probably guess, it spins fast. It has metallic hydrogen, this compressed hydrogen. Of course, then it's going to have a magnetic field. No surprise there. Now, what is kind of surprising is it gives off quite a bit more heat than it receives from the sun. Again, that's surprising because it's so far from the sun. It's not as big as Jupiter. We're going to call this mystery number 2. They don't think that Saturn held on to this heat the way Jupiter did. So how can this be explained? Well, we're going to combine our 2 mysteries. The first mystery was there's kind of a lack of helium in the atmosphere. The second mystery is that there's an excess of heat. Voila. Here is an idea, hypothesis that says maybe it rains helium, and the raining of the helium, the potential energy eventually turning into heat energy, is what gives it that extra heat. So that's pretty cool. Helium precipitation sounds good to me. And if that was true, then Jupiter, as it cooled off, would eventually have helium precipitation as well. We'd have to wait maybe about 1 billion years or so for that to happen. So I don't think we'll be testing it that way, but I'm sure they'll find a clever way to test out whether that's the case. And there's a look inside Saturn, and see, this time the gaseous layer is what on Jupiter, the liquid layer was the greatest part of the volume, and here it's the gaseous layer, so that's why it's not as dense. That white layer right in there around the core, though, is the metallic hydrogen, which is important for that super strong magnetic field, which is 1,000 times stronger than Earth's magnetic field, which produces northern and southern lights and gives off radio signals. In this case, it's harder to detect Saturn because it's actually in the AM part of the dial, and that tends to bounce off our atmosphere instead of coming through. It's why AM gets a lot more affected, by the way, by storms and lightning and things like that, because it interacts more with the ionosphere. But anyway, next time we will talk about Saturn's amazing rings. Thanks for listening.